Hello everybody and welcome to today's presentation, Analyst to Engineer, Q&A on Cloud Data Warehousing, brought to you by Fivetran. Before we get started, I'd like to take care of a couple housekeeping items. First off, I'd like to make sure you all can hear me okay, so if you would, send me a quick message in the chat window to let me know you can hear me okay. Great. If you have any questions for our presenters today, please post those into the questions panel so we can get to them after the presentation. If you experienced any technical difficulties today, like the audio dropping out or the screen sharing not displaying properly, please post a message in the chat panel and I will work with you to resolve those issues. Lastly, on the housekeeping list, we are recording today's presentation and will be making it available shortly after today's event concludes. Now that we're through the housekeeping items, I'd like to introduce our presenters. Fraser Harris, who is the head of product at Fivetran. I'd like to do a quick sound check for Fraser. So Fraser, if you would like to say hello to our audience, and audience, please let me know if you can hear Fraser by posting a message in the chat panel.
Hello, audience.
Awesome. I'd also like to introduce Gargin Ordain, who is the analysis lead at Fivetran. I'd like to do a sound check for Gargin. So Gargin, if you would like to say hello to our audience, and audience, let me know if you can hear Gargin by posting a message in the chat panel.
Hello, everyone.
Awesome. And without further ado, I'm going to turn things over to Fraser to begin the presentation.
Hey guys, so let's talk about, we're going to go through cloud data warehousing today. I'm Fraser, Director of Product at Fivetran. I've got about 8 years doing cloud development on AWS, Google Cloud, and my focus here at Fivetran is creating great schemas for analysts.
This is Gargin. I am the analytics lead at Fivetran. I have about 5 years of consulting experience doing reporting using various different tools in the healthcare industry, and my focus here is the internal analytics.
So this is our agenda. We're quickly going to talk about on-prem, what BI used to look like and what the challenges were there, and then how the cloud has changed that, and then the modern BI stack built on these new capabilities of the cloud. And then we're going to show you an example of how we're using a cloud BI tool internally at Fivetran, and then Q&A. So to start with, this is what like your classic BI stack looked like with ETL, extract, transform, load. The key here is that everything was defined by this, or limited by this slow relational database, and that's really why this whole model exists, was trying to take the data that you have from your sources, be it applications, databases, event sources, and trying to shrink it down in the transform, doing your modeling and aggregations so that it would fit within your database. And then ultimately you'd be extracting that like as a data mart onto your local machine, your desktop computer, to actually do your visualizations and reporting. And there was a bunch of problems with this model, which Gargin can dive into.
Yeah, so I guess the classic ETL, the main problems that I've discovered with it is that there's a lot of times a lot of communications issues with the team that needs to actually display the data and the engineering team that actually creates the transforms. Usually what happens is the client comes to you and says, we would like to display A, B, C visualizations, and then you kind of figure out which transforms and in which format you need the data to be in order for you to be able to actually display the data that way. However, you usually do not have the power to actually make those transforms. So you have to talk to a different department and kind of give them guidance of how those aggregations need to be done before they're even loaded into the warehouse.
So you're doing this within healthcare?
Correct. So what would happen is our client would hire us, the consulting firm, to build dashboards for them. This particular client was doing it in Tableau. And then we would basically talk to their data team and what they would do, they would aggregate the raw data and then based on our requests, transform it in basically the normalized pivot tables that we would want. And that would take some time. That would take about 3 to 4 weeks every time we had a request for them to actually check that they can do it, that it does not interfere with anything else that they're doing, allocate time for it. And then they would just load it to Redshift in this instance. And what we would do then would either download the entire data and include it with the workbook when we load it into the Tableau server, or we could just hook straight to Redshift. But the problem was that all of the aggregations were already done, and a lot of times we had no visibility to how they actually did the aggregations. Sometimes, I guess a classic example is when you're trying to do an average of something, and there's some people do average of averages, some people do the entire sum over the entire count, and we just had no idea how they did it, because we would just get the already transformed aggregated data. And what would happen is, in some cases, we would be able to know right away that things are wrong. Sometimes things would be over 100% when they possibly couldn't be if the aggregation was done correctly, and we would address those right away, and then they would fix it.
When you say they would fix it, how long are you talking about?
Probably another couple weeks, because there was always other requests that we had. It was just kind of a back and forth communication. This whole project lasted for about 6 months before we even went live with the reports. But additional challenges were sometimes we actually couldn't tell that the data was wrong.
Right.
Because it's hard for me to know how much, let's say, the Walnut Creek territory had sales. There's just no way for me to know until the report actually gets to the sales rep, and then they say, no, I didn't have 500, I had 1,200.
Yeah.
And then now that's an additional challenge. Now the report went live. Yes, it's mostly to test users initially, but now they have to come back to us. We have to go back to the engineering team, understand where it went wrong.
So it's funny, you're talking about using a cloud data warehouse in Redshift, but you're actually using it as a traditional database. You're pre-aggregating all the data. You're not benefiting from the fact that it's a columnar warehouse.
That's right.
With massive parallel processing.
Yeah, and that's I think that's because they were using the classic process.
Yeah.
Right, just the classic ETL. You extract the data from the raw sources, you transform it to the needs of your user, and then you load it. And your user cannot see how those aggregations were done.
Yeah.
And the problem is a lot of times the message gets lost between the user and the person aggregating it.
Right. So all these classic problems of ETL, extensive planning. You're doing this like 3 to 6 month project. You have to plan way in advance, and the iteration cycles are so slow. This setup is insane.
Yeah.
You have to wire up every field that you want and figure out what every single aggregation is in advance.
A number of people that you have working on this is also crazy. You have a huge team of analysts, planning what needs to be displayed, and then again another team of engineers that actually try to do these things. A lot of people in between trying to make sure that all the communications are done right.
Yeah.
So yeah, it's definitely expensive.
And then the ongoing maintenance of all these pipelines. Like now that you've built these processes, anytime something goes wrong, it's like, oh, back to the engineering team, back to that 2 to 3 week, 4 week process of, you guys have to fix this.
And many delays as well.
Yeah. So just a whole bunch of problems with this existing setup. That being said, like it exists for a reason because of that slow relational database. This was the best that you could do. So things have changed. The cloud is fundamentally changed a bunch of things. So the first is that all software, or most software, is now standardized in the cloud. People are adopting Salesforce en masse or Zendesk for support. And the benefit of that is you now have a single data model across there, or at least very similar data models. And you don't have to reinvent the wheel every time you're dealing with these different pieces of software. The other one is that because it's in the cloud, they all have standard interfaces. So the APIs are all the same. So that means you don't have to reinvent connecting to Salesforce and extracting that data or Postgres database for that matter, or you've got flat files sitting in some file storage like in S3 in AWS. So all of these have common interfaces, which means there's a big opportunity here to build off-the-shelf tools for all of these platforms, rather than all that custom logic we previously had.
And then the advantages of using these standardized platforms is that people have really thought about this. They've kind of had a lot of clients and they've covered a lot of the edge cases. And chances are, if you try to reinvent it, you're gonna have to go through iterations to get it as perfect as the standard platform already has.
Right. Yeah, I love working with the Salesforce API. It's like, wait, this table has deletes in some other way, and it's like, oh, this one has these other behaviors.
There has to be a reason, right? There's the reason why they did it that way.
Yeah. And so the other major change is that data storage is now practically free. Back in 1966, it was about $1 million to store a gigabyte of data, and today it's something like 2 cents. And on AWS, their file storage service is called S3, Simple Storage Service. They're charging about 2 cents per gigabyte per month, but that's triply replicated across different zones. So you have like an absolute safe backup, which these prices are just crazy. Like, why are you trying to store, stuff the data as small as possible inside of this small, very expensive database where you can just store it all as a replica that analysts have access to? This is like a fundamental shift in technology. And the final one is that compute power is now instantly scalable. It's really like a dial. Like, you can go into the interface and just be like, I need 12 more nodes in my cluster, please, for 15 minutes. And it's amazing. On the one hand, you've got like AWS Redshift, which came out about 6 years ago. And so that was kind of the first warehouse that really took advantage of what the cloud has to offer. So scaling still takes, it takes about 30 minutes, and you have to go through this process to say double your cluster size. But that was still a revelation versus the on-prem systems beforehand, where it was let's go back to Teradata and commit to another, $500,000, multi-year contract to increase the size of our cluster. Those days are gone.
Yeah, it's a lot more dynamic now. It's just, it's again, as far as it's practically free to store all of your data. You don't have to do all of these transforms and think about how you need to use the data. Just load the raw data in there. There's just every transformation that you would do and get a result and store that result, you can just store the raw data and then do the transformation as needed, right on the warehouse, right, with the huge compute power that you now get at the time that you need.
Yeah.
So I feel like that's just a fundamental change.
Yeah, our advice to customers is always first thing you do is just use a view, and your socks will be knocked off as how fast these massively parallel systems can be in terms of just on the fly computing these aggregations.
That's right.
Yeah.
And that's because some time ago, people just didn't have that option. It was just too slow, and it was just too complicated to manage how much compute power do you need to purchase and all this. But now everything is becoming dynamic. You don't even have to worry about it. You just store your data, and when you need to run a query to get a visualization, your BI tool, you just run the query, and then everything happens behind the curtains.
Yeah. So all of these three major changes, standardized software and schemas and APIs, extremely cheap storage, and compute that's extremely dynamic, has resulted in the new modern data warehouse architecture. And the fundamental piece is the separation of compute and storage. So in the previous generation of technology, you had on-prem, Teradata or Greenplum or Vertica or Netezza, and they were massively parallel processing systems, so clusters and nodes, and you could distribute the query across the nodes in the cluster. But fundamentally, you were still bounded by how much storage you had on the cluster itself. In the cloud, those two things are now separated. So storage is done in flat files in S3, or in the case of like Google's BigQuery, it's done, I think, what's their new under the hood thing called? It was called Bigtable for a while, but
yeah.
And only on demand, when you want to query data, is it pulled out of the flat file storage onto the nodes of the cluster and then computed. And then, under the hood, they're doing all sorts of optimizations about what you cache on the clusters to make the queries like really fast, the common queries really fast.
That's right. Yeah, BigQuery especially has fantastic query optimizations where you can actually see it when you run the query. If you run a query and then there's a little details button, and you can just click on it and you can see how it actually transformed all of your query and moved all of your where clauses to the basically all the subqueries inside to only the query the portion of the data that you need.
Yeah.
To minimize the compute.
Yeah. And the second piece of the modern data warehouse is that there's really zero infrastructure management. You just have a UI interface, and a lot of the details are now abstracted away from you. So when we talk in this modern architecture, the two ones that are really leading is Snowflake, which is can be deployed on AWS or on Azure, and then there's Google's BigQuery. In AWS's Redshift is kind of starting to show a bit of its age. We're interested to see where it goes from here. But in terms of this, it doesn't have the separation of compute and storage in the way these other two do, and the way that there's zero infrastructure management. And the last one is the support for structured and unstructured data. Because these systems are just pulling flat files and just running through the data so quickly, you can do all sorts of things that you previously couldn't do with unstructured data, where you don't need to type it, you don't need to index it or sort it, and it's just the performance is unreal.
Yeah, when I moved to a lot of times I was running processes using SAS, and when I moved to BigQuery and understood how fast it's able to aggregate the millions of rows of data just under seconds, right? Just do the aggregations, and that's because of the dynamic compute power that we get. Right? It's just like he just allocates as much as he needs at the moment and just runs it and then deallocates it.
Yeah.
So yeah.
Yeah, that's the big difference between, like, BigQuery is kind of the logical extreme of where you take this, where in fact you have no idea. The whole concept of compute nodes or anything is abstracted away from you, and you just pay per query. So you just have your query, you run it, and that's that. As far as you're concerned, that's it. Like, and who knows what's really going on under the hood, right? And how many nodes were dedicated to this?
You don't have to worry about it.
Yeah, and kind of a halfway mark is Snowflake, where you still can provision warehouses on the fly, and in fact, multiple teams can have warehouses that turn on and off, like down to the per second billing, and you can configure the number of nodes, and you can configure it, allow it to dynamically scale on the fly as big as it needs. It's pretty amazing, but that gives you more control than BigQuery. So it's kind of in between, So that's the modern data warehouse. And what that leads to is now, in that previous slide where we've got ETL constrained by the relational database or the slow database, that's no longer the case. And as a result, the whole BI stack can evolve. And really, it evolves in a way that avoids all those problems that we were talking about.
That's right.
So in the modern BI stack, it's instead of extract, transform, load, you extract, load, and then you run the transforms in the warehouse. And so speaking to this extract load, you're creating a full schema replication, a data lake within your warehouse. And you don't worry about that storage cost because it's practically free. And we see that, like, with customers like, for example, on Snowflake, you can see their bills, and it's like 3% data storage and 97% compute. It's like there's just no cost to storing the data.
That's right. And the another advantage of doing it this way is that you actually lose no details of your data, right? Your entire raw data is there, and if you decide to do aggregation one way and then change your mind halfway through and you want to do it a different way, your raw data is still there. You just change the way the aggregation is done in a transform, and that's it.
Yeah. So your process as an analyst goes from being dependent on your engineering team and having to continually go back to them, being like, hey, let's fix this. I need this fixed.
Right.
And instead,
you get to define everything that you're going to aggregate. You get to define it yourself. You see how it's being done. There is no communication barrier. There is no just kind of messages being lost of how something needs to be done. You just basically see everything from the very beginning, very raw data that comes through to the result that you get. And if something ends up being wrong, you have the power to, as an analyst, to go in yourself and investigate what's going on, which makes things go from 4 months to 4 weeks.
Yeah. And fundamentally, your process is now like, it formerly was this waterfall process of defining specs and then like, the cascade of Q&A and whatnot. And now it's really embracing agile. Like you can iteratively, our end result is going to be this, broader analysis, but we're going to start by, let's just do this piece. Let's see how that goes. And then along the way, all these new questions keep coming up, and it's like, okay, well, I can answer that too. That's just a little bit of an iteration on what I'm currently doing, and you move outwards, and you end up with some really cool results that otherwise, might not have happened just because the process takes so long.
That's right, and you're a lot more educated about how the process actually works. It's just you're just like a one go-to man that the client needs, right? They just go to you like, hey, like, how is this done, or can we change this? And you can just say yes or no. You don't have to be like, well, let's schedule a call with the IT team and see when they can get the data, so that we can schedule a time and see how far we can transform it, when we can get it by. All of that is eliminated. Yeah. Now you just have, okay, yeah, we can just change the query. You'll just show in your BI tool. That's it.
Yeah. So the transform layer is moved into the warehouse, and it's now SQL based. So instead of doing your aggregations and modeling using scripting languages or programming languages, it's standardizing against SQL. And then your visualization layer is a BI tool that runs directly executed against the data warehouse. And we did see that in the previous generation, like the Teradatas and Atizas on-prem. But this is like the terminal result of that. And so your BI tool can get smarter, like a Looker, where it's centralized and has a modeling layer that everyone can use. So you have one definition of what revenue means, or one definition of what an employee means that everyone can share. So you get a huge benefit there of being able to reuse your models and reuse your results across all of those reports.
That's correct. Yes.
Because we all know how freaking tricky it is to get those things right.
Yeah, there's one example is actually calculating a churn a few different ways. I read an article where basically there's just no one defined way of calculating churn. People just do it.
What's churn?
Well, churn, speaking generally, is loss of your business. I guess you can say percent churn or unit churn, and percent would be like percent of your business that you lose, but it's not clearly defined, right? It's just percent of what's your denominator. What are you dividing it by? Is it your total business this month? Was it your total business at the beginning of the month? And it's just important to be able to come up with definitions that everyone will use as the truth.
Yeah.
And yeah, this helps with that.
Yeah. Yeah, and it's like tricky things like, oh, this customer renewed 3 days after the end of their
Yeah, do they count? Do they count as the base, or do they not?
Yeah, is that a new contract, or is that a renewal?
Yeah, what if someone came back 2 months later?
Yeah, and then you end up with, everyone's seen it, right? You end up with these situations where you're in a meeting and someone's like, my numbers say blah, and it's like, well, my numbers say blah. It's like, we should totally do this completely different decision based on these numbers. Whose numbers are correct, right?
Yeah.
So, in the modern BI stack, instead of everyone punching away on Tableau on their own desktop, coming up with their own conclusions, you're able to share those rapidly across the company, and everyone can, be able to see, like they can dig in and actually see how the numbers were generated. And so
effectively, the analytics team would do a lot of just brainstorming and thinking about the right way of coming up with these definitions and the advantages and disadvantages in each definition, wherever a clear definition is not available. And that comes back to the same idea of that, when someone did all of the hard thinking and the decision making, now you can just kind of trust that number, and you don't have to, like, different teams don't have to analyze how to come up with certain metrics. One of the teams did a lot of investment in time and in thinking and coming up with these answers, and now the entire company can use all of these figures.
Yeah. And so, we've really talked about this or alluded to this, but over the past 30 years, there's been a real drive that empowering the analyst. And over time, like, the analyst chunk of the BI stack is becoming more and more. And that's because more and more of the tools in this BI stack are now automated. It's very and I talked about this with our CEO. It's like, how did data warehouses become the fully automated data processing system? Like, databases can't. They're finicky. It's very hard to make them fully automated. But data warehouses have a huge advantage, and in that you've got this massive parallel processing in a columnar warehouse, and you don't have to support all of these weird data access methods. It's actually a very narrowly defined way that you can access data in a data warehouse. And as a result, you don't have to provide all these different ways to potentially optimize how to access the data. And I think there's like a fundamental insight there, and that's why data warehouses become so automated that the IT team no longer has to manage it. And then in the cloud, like, the analyst can manage the whole thing without spending that much time truly having to understand what's going on under the hood. There's still cases where it very much helps. You need to set indexes sometimes, and that can improve your performance. But the reality is, with these systems, it's like,
most of the time, 95% of the time, they're just good enough the way they are. You can just utilize them that way.
Yeah, it's like, what are you optimizing? Like, your home time is so valuable, and the warehouse is so cheap. It's like, we'll just throw a view on this. If it costs us more than a few $100s, maybe we'll actually see what, if there's some materialization that needs to happen here, or we need to, like, index something.
That's right. Most of the time you won't have to do it, though.
Yeah. Like, our rule of thumb is, like, until you have 100 million rows in a table, it's not worth optimizing at all. And in fact, it's like, because they're distributing the query across so many nodes with less than 100 million rows, if you try and optimize, you might actually go in the wrong direction, because it's already splitting up the query into so many, like, partitioning it across the query planner is doing that across the nodes. That it's not even worth it. So you want to dive into an example of how we're using it?
Yeah. So I'll just kind of go over how we have one example of how we have actually utilized the cloud data warehouse for our own needs. So there's this Looker dashboard that I have built. This is kind of showing, for example, how one of our clients is kind of a dummy name that I came up with because I didn't want to display all of the details for our actual clients.
Can you zoom that in?
Let me see. Yeah.
It looks tiny.
It's got to be way perfect.
Like, I've got great vision and I can hardly see that.
All right. That should be better, I hope.
One more.
All right.
Oh, yeah. Look at those big numbers.
Nice. So this is an example where someone would just kind of log into their, a user of our own firm would log into their Looker instance, and just if they wanted to see how a particular client is doing, would just filter to that client and just click run. and within 10 seconds, they would have all of this data aggregated and displayed. It would show them, the usage of all different connectors that we offer. It would show, over time, what they're using the most. We could definitely look into why, for example, there was 13.3 billion rows synced for this. It's usually like a huge change. This could be, Fraser, am I correct? This could be if they changed like a column type or something like that, or resync the entire table, and then that would just.
They probably had to resync their database different times. They're probably doing some pretty significant changes at the point. It's probably good at this point to frame what we actually do at Fivetran.
Yeah.
We built data connectors to sync all these data sources into your data warehouse in minutes. We've standardized the whole process, just off the shelf. Analysts can connect up things, like you can connect up Salesforce or a database, and literally it takes 5 minutes to set up, and then boom, your data is this full replication into your data warehouse.
Yeah,
it's pretty neat.
Yeah, so this is kind of this would be one of our clients, for example, that would be using our product, and we would be able to see which of our products are these clients using, what have they purchased, and how much are they actually using of their purchases, what are their bookings, when they're coming up for renewal, as well as all their connector people who connected them, the status of the integration, is it syncing, is it updating, or is it already already? As well as we were able to pull in different sources here. We were able to pull in Salesforce, GitHub.
So GitHub is our software development tool that's tracking all of our issues.
That's right. And sometimes, because we work with our clients so closely and we have very active support, a lot of times, if a client has a request, we'll create a GitHub ticket and say oh, we want, change the color of this thing from, let's say, green to gray, and then we'll create a ticket for it, prioritize it, and then get it done.
So how many data sources are going into this one dashboard?
For this particular one, I think we have Salesforce, we have GitHub, and then we have our own internal Postgres that tracks all the connectors.
Yeah.
But it's really not limited to 3. You could have as many as you need. And that's that's the beauty of using Fivetran. It's just you just hook up as many connectors from the hundreds that we offer to your warehouse, and you get live sync, right? You get 5-minute live updates on your warehouse. And once you define your BI tool queries and looks, you actually never have to change any of them anymore. Your data just keeps updating, and then every time you just click run, it just pulls a new data from your warehouse.
Can you show us what that looks like?
Yeah, absolutely. So I guess I can just go over some of the our models and our queries that we've defined. So I've come up with certain queries that I've thought really hard about, and make sure that this logic is all correct, and everyone just kind of uses these views, right? I only have to define these once, and if I want to pull the Salesforce cases, I just this is kind of like a more or less simple query.
On that scrolling. You're gonna give people like a seizure.
So if I want to pull the Salesforce cases, I can just kind of pull the case table and add the account on it and the owner of the account, and that way people can just go and filter to themselves and look at their own cases and for their accounts. For example, here I'm doing some volume updates for our connectors. Which connectors are using which volume, and what we're able to see is kind of look at our internal database volume, and then add the Salesforce information as well as the webhook updates, and then define some dimensions and measures by which people can actually filter.
So it's interesting, in there you're using a lot of common table expressions. With PG as.
Yeah, it's so it's just the way you kind of do it in Looker. You just you come up with a bunch of little tables or views here that you define. Then at the end you aggregate them into a single table, and then off that single table you define a lot of dimensions and measures that you can use to filter.
So this is LookML, their markup language.
That's right. That's right. There are also sometimes cases where if I have to do like if I have a connector that I'll be if I have a view that I'll be using a lot in many different views, I'll kind of define this logic in a single location, and then I'll reference that logic in in my other views, so that I don't have to replicate the same logic in many different places. If I have to change it, I can just change it once in a single location.
Got it.
There are definitely different ways you can utilize Looker. You could kind of use the traditional joins in the Explorer to connect your views, or you can just define all of your views to be standalone and then utilize them by themselves. It kind of depends on your data structure and the type of the aggregation that you're doing. Yeah, but that's basically the analyst can make all of those decisions and figure out what the best way is to display their data for themselves.
Cool. And then I think the coolest thing is you find all this, and then anyone in our company can just like come in and look at how is a certain account doing.
That's right. So what you'll be able to do is you can go, oh, I want to go to, let's say, the connector volume, and then this is available to everyone, right? They could just kind of create like the connector name, and then the service as well as the volume, and then just run it and come up with the numbers right there and then. They don't have to come and talk to me and say, hey, I want to know how much volume this person is using. No, you click on the export, click on that client name, the month that you're interested in or the quarter you're interested in, click run. There you have it.
Right, so because you've defined that modeling layer, that one source of truth, you no longer have to have that like lineup of users coming to the BI team being like, standing in line for a week, like, hey, I need my report. Can you guys generate this insight for me?
That's right. And the main advantage of Looker is that, yes, I built some dashboards, but people are actually able to use the explorers themselves and build their own dashboards based on the modeling layer that I've defined.
Yeah.
So they're not that dependent on just me building dashboards for them, right? It's more about me providing them the tools that they can do zero code dashboard building for themselves.
Yeah. And this is like a fundamental shift that the modern BI stack enables. You as the analyst, instead of being part of this huge waterfall process, it's now you're managing your entire stack below you. And instead of this like red line of people like, oh, I need my what would you like today? It's in fact just like, here is a smorgasbord of things that I've created that you can work with to answer your own question.
That's right. You can provide them with a tool. Right?
Yeah.
What was that saying? Teach someone how to fish. And...
Yeah. Very cool.
Yeah. Are there any questions, I guess, that we have from the audience?
Yeah, I guess that's a good point.
Yeah, we do have a question that came in. What are the advantages of using BI tools versus Excel for reporting?
Cool. So Excel is probably like the most traditional and probably still most widely used reporting tool. The advantages of using BI tools is that with the cloud data warehouse is that if you have a process that already syncs your data into your warehouse, you just define the queries and the logic that the BI tool needs to pull the information with, and then you never have to worry about it again. It's live. You will update itself as the user uses it. With Excel, you kind of have to download the data, pre-aggregate it, and then paste it in the right format. And every report for any point in time, you have to regenerate and deliver. And you have to generate for every user, right? If you have 400 reps, then you have to make 400 reports, which can be somewhat automated to do in terms of actually, like, you don't have to save, you don't have to click save on 400 reports. So there's some code you can write to help with that, but you still have to make it. There's still a lot of manual labor involved. With the BI tool, it's just, if you've done your logic correctly and your data fits in, then you just build it once. This is your BI tool at any point in time. Yeah. And people just go and you can utilize Looker user attribute functionality, where a user goes and logs in and it just shows the report filtered to them.
Right.
That's that's what I've done here. I don't have to worry about someone going in and like having to click on a bunch of buttons to get to where they need. No, just with the username of the person actually using the Looker instance, is just they're able to understand who it is and filter to all of the accounts or whatever sales that are relevant to this person.
Yeah, and you can, and that permissioning goes down your stack. Like we have a bunch of customers that are thinking, centralizing their data, say in Snowflake, and they're using the user permissioning in Snowflake and the group permissioning to define who gets access to what, and that can be down to the column level. So you have like PII or sensitive data, you just exclude those columns from what that user has access to or that group has access to, and so you have not only you're providing this full data mart effectively.
That's right. And I guess to summarize it in 2 sentences, it's more about like a fixed cost versus variable cost. You just do it once, and then there's just basically no more maintenance. It just does itself the rest of the time. Versus if you do something in Excel, it's just you have to keep doing it every time. Every time you generate something new, and most of the time, you'll be generating them weekly or at most daily. But using the iTools, you have this 5 or 10 minute think time. You just made a sale, you load it into Salesforce, boom, it's on your dashboard 10 minutes later.
Yeah. Billy?
Great. Our next question is, what are the differences between cloud data warehouses?
Yeah. So I think I've alluded to some of them, but there's kind of 4 major ones on the 3 major cloud platforms today are AWS, and they've got natively their Redshift. Redshift. They also have Athena, which is another data warehouse built on top of the open source project Presto. It's interesting. You kind of spin it up on whenever you need it. It's definitely rough around the edges. AWS Redshift itself, as I said, is starting to show its age. It is still defined very much. You have a certain number of nodes in your cluster. You're constrained by how much storage you can have on the nodes. Azure also has the Azure SQL Data Warehouse, which is still it's live, it's in general availability, but it's relatively new, and they're making some progress there for sure. It has a lot of the benefits of being more scalable, but still it inherited a lot of things being a derivative of SQL Server that don't make as much sense anymore in the way that BigQuery, Snowflake have just reinvented data warehousing for the cloud. So the real leaders we see are Snowflake, which is it's its own company purely doing data warehousing, And you can run Snowflake on AWS, or it's coming out in the next couple of months on Azure. And it is a fantastic product, extremely cool. We see them really rising extremely quickly. The other one that is really leading edge technology, like no surprise coming out of Google, is BigQuery. And they've kind of got an interesting strategy where they give you free data exports from all the major Google tools like AdWords and DoubleClick for publishers and one now called DoubleClick Bid Manager. You get all these free exports of data to BigQuery, so they're really trying hard to get people to adopt it more. Very cool product, but it's a very different pricing model where you pay per query as opposed to paying for some kind of compute capacity. We found that per query, it's about twice as expensive than a Snowflake or a Redshift, where you're purchasing upfront your capacity. But if your load is very uneven, so if you've got just like people randomly firing off queries, unbelievably cheap. But if you have a pretty steady load, then the pricing model kind of falls apart, and it makes a lot more sense to go with something where you have where you're more invested in that capacity, like a Snowflake. And our kind of internal rule of thumb is like once your cluster is seeing around 30% usage, then it makes more sense just to pay for it outright. Snowflake does have a lot of really cool ways to bring down your costs. So it's per second billing, and it's got auto suspend after 60 seconds. Your whole cluster just goes to sleep. You stop paying for it if no one uses it for 60 seconds. And then it can spin right back up when you need it. So you can have 1,000 users during the day putting like a high level of utilization on your cluster, and then come like 6 p.m. the cluster just turns off and you don't pay for it overnight. Really nice ways to return those costs.
Awesome. Our next question is there a size of a business that you suggest where it would be cost effective to transition from traditional to cloud data warehousing?
There's so many easy ways to get started now. Like you can use, an individual, like let's say you're a 30-person company and you've got your first data analyst. That person could be working on top of BigQuery. They would literally be spending $10 or $20 a month in queries because it's just the load just isn't there. And the data volume just isn't there to really cost anything. You can use using a BI tool like a Chartio or a Periscope, like in the cloud BI tool. Once again, spending like on the low end, if you've got one user, $10, $15 a month, and taking advantage of all of this new technology and being able to do all this really cool analysis and supporting the company in the same way. So I have a really hard time seeing like why anyone would make that trade-off. Granted, you do have to learn some new things. Like you got to learn some new tricks. Like you've got it's not like using Excel anymore, but it's so easy and it just naturally scales up from there. So as you grow a team, like as you go from 1 to 5 analysts, you've got all the scaffolding there to grow with them. And you're not like trading Excel documents and then having that painful realization like, oh God, like we need more structure around our data. What does that next step look like?
It definitely starts to make a difference as your team grows. But as your company becomes bigger and bigger, it's going to make more impact that way because it scales much better, as Fraser said, compared to having to build more and more custom reports and dashboards versus being able to set up a process that way all of your users can realize it themselves.
Yeah. And in like large customers we have, we see them. It's funny, the different groups actually kind of splinter on what BI tools they're using. It's all working off of the same common data sets. But one example, this is like they're a tech startup and they're worth, I don't know, about $10 billion today. But the majority of the company uses Looker, so that they've got thousands of end users. The finance team uses Tableau, and then the executive team uses Chartio, because the executive team just wants to, like, as fast as possible, pounding out these little dashboards that are, whatever the theme of the month is, or what, the board meeting, like this, the questions they're trying to answer to give insight to the next quarter. But you see that kind of splintering where, for different use cases, you end up using different tools.
Yeah, you're all hooked up to the same warehouse, right?
Yeah, yeah. Well, in their case, they're actually running 2 parallel warehouses.
Great. Our next question is, how do I convince my company to trust a cloud warehouse?
Wow. I mean, like, for me, it's the opposite. Like, how do I convince my company that we should trust that we're going to do it right on-prem and, like, have this high availability when it's got, like, I kind of get, like, the examples, like, Hillary Clinton's email server. It's like, my God, I wouldn't trust anyone with my email except for Google. Like, They pay those guys so much money, and, like, every time I'm, like, hanging out with them,
they've done all the thinking.
Yeah, they've done all the thinking.
Secure.
Yeah, it's like, why wouldn't I take advantage of, like, these systems with unbelievable uptime and unbelievable engineering resources? Like, who am I to think that my team's gonna be able to? Well, granted, at 5chain we've got some incredibly smart guys. Like, the core of the team are a group of neuroscientists from Carnegie Mellon, so we've got a real brain trust here too. But I want to take advantage as much as possible of other teams that are thinking that hard about these things.
Yeah, there's people there whose entire job, right? There's a number of people who like making sure these things are secure.
Yeah,
and they do it for hundreds and thousands of clients. So I'd be very confident to trust Google with my data versus me storing it at a hard drive at my house, because anyone can just break into my house and take my hard drive.
Yeah, I remember my friends at Google, and or many, but one of them in particular was telling me about a time they were randomly poking around on the Google network. There was actually a reason for it. I can't remember what, but for some reason he had to go access something on a different team's data. And within like 5 minutes, there was a phone call at his desk from the security team being like, "What are you doing? Like, why are you doing this?" In nicer tones, right? Like, but the amount of like logging and data security there far surpasses anything that you're going to bake up at home, unless you're like investing, millions and millions of dollars like a bank would. So I would definitely turn the question around and be like, what makes you think that our on-prem system is going to be safer?
Yeah, it's reinventing the bicycle. Someone already made a really good bike. Will you be able to design a bike just as good? Maybe, but I'll take the top brand name, right?
Another question we got in was, how does Hadoop ecosystem compare to a cloud data warehouse?
Oh yeah, that's actually really interesting. So like Google kind of the heart of like we've all heard the story of like the Google search is so great because it's got PageRank and it ranks everything on links. And the real at the core, the real innovation, computer science innovation, was MapReduce, which is this technology massively parallel, like to an unbelievable extent, where it just performs a function, that's the mapping, and then it just sums it up. And so that was like counting the number of links, to a website, right? And that was the core of the innovation. And then that got publicized, and eventually an open source project got built on top of it called Hadoop. So it's just MapReduce that you can run yourself on your own computing cluster. One at the heart of it was a really good idea that's been kind of co-opted into cloud data warehouses, which is that your data is just stored on flat files. And in Hadoop, you can have many different file systems. FS is a really popular one, but there's a bunch of others, HBase and whatnot. And that technology really peaked kind of in the last 5 years, and it has widespread adoption in a number of players out there like Cloudera and Hortonworks offering commercial versions of Hadoop. And even AWS has Elastic MapReduce, EMR, so you can run it as a service on top of your data in AWS. What we really see is, Hadoop is extremely useful for our big data processing, batch processing work. It's not as useful when you're trying to provide dashboards or analytics to individuals in your company. And so when we see customers using Hadoop, often they're running a data warehouse in parallel. And sometimes, most of the time, the Hadoop process is doing some huge batch data process and then outputting to the data warehouse. And then the end users are all running their queries off the data warehouse. So these things are usually used in parallel. Yeah.
Awesome. Looks like it will be our last question. What are the main differences between SAS and SQL?
It's a good question. So SAS is a tool that's used kind of on an on-prem data, and it's very flexible. It has a lot of, it's very powerful. It has a lot of, I guess, functionalities that SQL hasn't caught up to yet. It has a lot of error checking mechanisms as well as a lot of logging that you can do free or through, while you're aggregating data, and that can kind of help you do a lot of checks and quality control in your data before you move it to whether it's in Excel or in your BI tool. But the disadvantage is that it's not as quick as SQL. SQL is basically instant. It can run against your cloud data warehouse and instantly display looks and visualization right in the BI tool as soon as the data appears in your warehouse. Versus with SAS, you would have to download the data, process it, get aggregations, and then load it to your whatever platform you're reporting it. So it definitely can be utilized in ways that SQL hasn't caught up to yet. But I feel like we're moving in a direction where instead of trying to utilize those things in SAS, SQL will actually catch up and be able to do some of these extra checks that you're able to do in SAS already.
Cool. Well, Billy, I think that's it for us here.
Yeah. I'd like to thank both of you for a great presentation today. I'd also like to thank today's sponsor, Fivetran, for providing the D-Zone audience with a great presentation. And lastly, thank you to everyone who joined us for today's presentation. We hope you learned something new today, and that'll help you in your developer career. Have a great day, and we'll see you next time.
Thank you.
Bye. Fivetran.com.